Hello everyone. Good evening. How are you all? So meeting you all after a long period of time, no? Hi Dinesh Verma, Ayanki, Rudransh, Tanuja, Veeraprasad, Wangtoy and JV Kadak students. How are you all? Hello. Hi. Are you all fine and good? And are you all safe? Yes. Good. So now, very good evening to all of you. Okay. Okay. You guys are so interested in listening to chemistry class. That's great. So happy for it. So now, before moving on to the session, I would like to launch a poll to check the class status. Okay, just let me know if I'm visible and audible. Am I visible and audible? Okay. I have launched a poll. You can give your answers over there. Okay. Am I not audible? So I'm audible to all of you, right? Okay, good. Now let's start with the today's session. So today we are going to start with a new topic which is called thermodynamics. Okay. So if you remember in the last session, we have completed the periodic table lesson. And in today's class, I am going to start with a new chapter called thermodynamics. Okay. Now, I'll start this chapter with a question. So why we are studying about thermodynamics? Why thermodynamics? I'll show you a picture, okay? So what is this? What is this? A tea is kept inside the container, no? In the cup and saucer, we have the tea. So if I keep this container with the tea in the table, what will happen? Will it remain hot for a long time or it will get cooled? What is your answer? If I keep this in an open atmosphere, what will happen? Will it remain hot for the whole day? Yeah, it will get cooled down. No, yeah, it will get cooled down. So the cooling of tea is happening when it is kept in an open atmosphere. Good. So now we'll go for another picture. What do you see here? A person is ironing the clothes, right? So what does this show? If I turn on the switch, electric energy is coming and it is getting transferred into the heat energy, right? So the ironing cloths involves the conversion of electrical energy to heat energy. So what has happened in both the cases? So some energy is transferred from one form to the another. Okay. So we are going to study about that transformation of energy in this entire lesson. Okay. So now let's go for the basics in thermodynamics. So in the basics, I'm going to cover these three topics. One is meaning and significance. Second is the key terms, which we are going to use in thermodynamics. And thirdly, the process and the properties in thermodynamics. Okay, so these are all the basic things we should know before entering into the thermodynamics. Okay, so let me start with the meaning and significance. So in the thermodynamics word, if you see, we have two terms. What are the two terms? Thermo and dynamics. Thermo means heat. Okay. Dynamics means movement. So what is the meaning? It deals with the thermodynamics deals with the movement of heat and related quantities such as energy. So mainly thermodynamics involves or it deals with the movement of heat and related quantities such as energy. Okay. So now the movement of heat in the sense, it deals with the study of transformation of energy from work energy to heat energy, and the heat may get converted to work. So this kind of transformation occurs, and it deals with energy changes for large number of molecules. It deals with the energy changes for large number of molecules. Okay. So all of you just give me a second. I will be back. Okay. Sorry for the interruption. I'll be back. Yeah. So thank you so much for your kind patience, students. So now coming to the second point, it deals with energy changes for large number of molecules. That is for macroscopic particles. Only for the bulk system, it is applicable. Okay, you see here, macroscopic means I have a container and I have a molecule inside it. And this whole thing is considered to be a macroscopic system. And if I take that one particular molecule, that is called as a microscopic thing. So we did not deal with the microscopic part. It deals only with the macroscopic systems. Okay. And the energy transformation of the initial state and final state of the system happens here. So what is the initial state? And after the transformation, what is the final state of the system? So that kind of information is being taught here. Okay. So this is about the basics. Okay, I mean the meaning and the significance, I can say. Meaning of thermodynamics. Now let's go for the significance. So there are three significance. So first significance is the determination of energy change and the transformation of energy in a process. So here in this picture, you are seeing a car, no? So here what is happening? We are putting a petrol and we put a diesel to this car, and that is actually a chemical. Petrol or diesel is a chemical. That chemical energy is getting converted into a mechanical energy, and that's how the car is running. Okay, it is utilizing the combustion energy of the fuel and it is running. Okay, so here some energy changes from chemical energy to mechanical energy is happening, and the thermodynamics determines that particular energy or the transformation changes happening in the process. This is significance number one. The second significance is it tells how whether the reaction is spontaneous or not. Spontaneous means continuous. Okay, the spontaneity and the driving force of the reaction can be found out from this thermodynamics. Okay, suppose I have a hot water inside the cold room. So what will happen? After some time, the hot water will get cooled down. Okay, but you tell me the cooling thing, which is the cold room, which has the temperature below 5 degrees Celsius. Will it make the hot water to get cool? That cold energy cannot be transferred to the hot water, right? So it shows the flow of heat from the container to the room, but not to the room to the container. Okay? The heat is flowing from the container to the room, but the heat cannot come back to the container again. Okay? So something is acting as a driving force here for this reaction to happen. Okay? The cold room air cannot come inside the hot water. So this is the significance number 2. Then coming to the third significance, it talks about the extent to which the reaction proceeds. So initially, in all the reactions, if you take, initially we have only the reactants. Only the reactant means reactant will be present in a larger amount. Mostly reactants will be there in the initial state. After some time, what happens? We will have equal number of reactants and products, right? So we call that point as the equilibrium point. Okay, the composition of reactant and product in the equilibrium mixture. After some time, what happens? After some time, we get the product. We get the product and their product molecules will be more in number compared to the reactant molecules. Okay. So the extent to which the reaction proceed can be found out using the thermodynamics. So these are the 3 significances of thermodynamics. Okay. So I have given you the meaning and the 3 significance of the thermodynamics. Do you have any doubt from this? First subtopic of the basics. Do any of you have any doubt from the students? Shall I go for the next topic? Okay. So I want all of you to interact in the class, not only 1 or 2 students. Okay. So feel free to interact. I'm not going to scare you. Okay. You don't have to get scared of seeing me or talking with me. Okay. You can feel free to talk. Now we'll go for the second subtopic, which is key terms in thermodynamics. Okay. So what are the terminologies, the basic terminologies we use here? The very first terminology we use in thermodynamics is system. Okay. So system is the part of the universe under study. The part of the universe under study. Suppose this is the universe. Okay. And I'm going to divide this universe into 4. This is region number 1, region 2, region 3, and region 4. I have 4 regions in my universe. Okay. So now I have been asked to take some statistical informations of region 1. I have been asked to take some statistical information of region 1. So what I will do, I will come to this region 1 area and I will take the statistical information. Okay, statistical information means, for example, I'm asked to check the percentage of girls who are below the age of 20. Okay, if I'm asked to find out the girls who are living in that region 1, who belongs to the age of 1 to 20. So that is actually one of the statistical information, right, which I'm going to take in that region 1. So what I'm doing, I am taking the observation. All the observations are made on region 1. So region 1 is actually the part of the universe and all the observations are made on that particular area. Means that is called as a system. This region 1 is called as a system. The part of the universe under study. The part of the universe under thermodynamic investigation is called as system. Okay, here in this picture you see. So this is called as a system. Why it is called as a system? We have a container. Inside the container, a piston is attached. This is called as a piston. Piston means the instrument which is used to give pressure. Okay. So the container is closed. And inside the container, I have some molecules, gas molecules, right? So that is those molecules are the system. So that is the part of the universe which is under study. Okay, all the observations are made on that particular gas molecule. Clear? So this is system. Next, coming to surroundings. What is surrounding? The remaining part of the universe is called as surrounding. Okay, the remaining part of the universe. So in the previous case, I have given you 4 regions, right? So region 1 was the system. Region 2, 3, 4 are the surrounding. The remaining part of the universe is called as surrounding. It may interact or it may not interact with the system. Okay, it can interact or it cannot interact with the system. So those things are called as surroundings. Then third is boundary. Third is boundary. What is this? Can you tell me what is a boundary? The one which separates the system and the surrounding. What is a boundary? The one which separates the system and the surrounding is called as boundary. So this is called as boundary because it is separating the system and the surrounding. Right? It is separating the system and the surrounding. It is called as boundary. Boundaries are of 2 types. So shall I go for the next slide, students? So is everything clear? All the 3 terminologies which I have discussed in this slide is clear to all of you? Say yes or no in the chat box. Yes? Okay, what about others? Only Veera Prasad and Ayanki is replying. What about others? Tinsukia. Okay. Good. So what I was saying, yeah, boundaries of 2 types. One is real boundary and the other one is imaginary boundary. Real boundary means you can see a picture here, no? I have a container and with the lid closed, okay, on this container. So the real boundary can be rigid or it can be flexible. The picture which you are seeing here now, it is actually a rigid boundary. It is a rigid boundary. Flexible boundaries are also there. So balloon is given as an example. You see here, it is flexible, right? We can stretch in and stretch out, no, but still that balloon is a boundary. So it can be flexible, means it can be movable or it can be rigid like a lid. Okay, lid or the wall of the container. So it can be rigid or it can be flexible, but both are real. We can able to see, we can able to touch. So it is real. And the second type is imaginary boundary. You see here in this picture. So here what is happening? I am boiling the water in a container. Okay. And the boiled water is producing the vapors, the water vapors. And the vapors are going. I don't know where it will go and get stopped. Okay, it will go and it will still go. I don't know whether the boundary ends here or it will go till this or it will end here or not. Okay. So this boundary, but boundary will be there, but we can't see. Okay, we cannot see the boundary. So those boundaries are called as imaginary boundary. Okay, so boundaries are of 2 types, real boundary and imaginary boundary. Now, what is an universe? System plus surrounding plus boundary is called as universe. Okay. Now let's go something in deep about the system. All right. So coming to the system and types, there are 3 types of system. One is open system. The other one is closed system. The third one is isolated system. What is meant by open system? Open system means the exchange of matter and energy takes place. Boundary is imaginary. So here what will happen? The energy and the matter, both will get exchanged. So suppose, if I take this, the same example I am taking. Okay. For imaginary boundary, I have taken one example. No, the same example I am taking. So here what is happening? Matter. Matter means the water which is present inside this. So it is getting exchanged. The water is getting converted into the water vapor. So matter is going inside from outside. And the energy is also exchanging, getting exchanged. From hot to the colder region, heat energy is going. So exchange of both matter and energy takes place. And the boundary is imaginary. Okay. So if these two are the cases, then the system is called as a open system. All right. So now coming to the second type of system, which is closed system. Here, only exchange of energy takes place. Only exchange of energy, no matter takes place. No exchange of matter, only exchange of energy. Okay. The boundary is a conducting wall. Conducting wall means if I give the heat energy, it will conduct. It will get boiled. But only the heat energy is transferring. But the matter which is present inside this container is not transferring because the lid is closed. No. We have closed the container. So the content or the matter which is present inside the beaker will not go to the surrounding. Okay. It will not get exchanged with the surrounding. But only the energy will get exchanged. So those systems are called as closed system. Now coming to isolated system, here no exchange of matter and no exchange of energy. Okay, matter will also not get exchanged, energy also will not get exchanged. Means the boundary is a non-conducting wall or the insulated wall I can say. So the best example I can give for isolated system is a flask. So we have a flask. The liquid or the food which we are going to store inside the flask will remain in the same position, right? It will not turn cold. The hot food will not get turned cold. The hot water will not get cold. So no exchange of energy and also there is no exchange of matter. The 1 liter water which I am going to keep inside the flask will remain as 1 liter after 1 hour and 2 hour also. Okay. So no exchange of matter and no exchange of energy. Boundary will not conduct. Okay. So if I try to heat this, it will not conduct. The heat energy, the heat will not go inside the container. Okay. The wall is made up of non-conducting wall kind of. Clear for all of you? So any doubt from the 3 types of system for anyone? Okay. So now I'll ask you one question. All clear. Okay. Name the types of thermodynamic system to which they belong. One is human body. Second is milk in thermos flask. Third is tea in steel kettle. Can you classify the type of system to which they belong? Go from the first. Take the human body. Tell me whether human body is an open system or closed system or isolated system. Human body is a closed or isolated or open system, students? Very good. It is the open system, right? Because both exchange of energy and exchange of matter takes place. You see there a person, no? He is sweating. So exchange of matter and exchange of energy taking place, no? Water from his body, this water droplets, it is coming out. So exchange of matter is also happening and also exchange of energy. So if the person is running or he is doing some work, he loses his energy, no? So both exchange of energy and exchange of matter takes place in the human body. So it is an open system. Okay. So Rakshita is saying that the milk in thermos flask is an isolated system. Very good. That is the correct answer. Thermos flask is an isolated system. What about the third one? Tea in steel kettle. Tea in steel kettle. Kettle means we'll use to have a lid, no? So it will be closed. So, but the metal is a steel. So we can keep a steel in a gas stove and we can heat it, no? So heat will be transferred. Energy is transferred. Heat energy is transferred, but not the matter. Okay? The tea which is present inside the steel kettle will not go as vapors. Okay, it will not get transferred to the surrounding. So it is an example for closed system. Okay, very good. Yeah, it is a closed system. So this is all about the second topic. So we have covered the meaning and significance and the types of systems we have discussed. Now we'll go for the process and properties in thermodynamics, which is the third topic of basics. So now let me go for the process first and then I will talk about the properties. Okay. So coming to the process, there are 5 types of process. Isothermal, isochoric, isobaric, cyclic and adiabatic. What is meant by isothermal process? First of all, iso means same. Iso means same. Thermal means temperature. Thermal means temperature. If the temperature is constant, then the process is called as isothermal process. Okay. So temperature is constant throughout the process. Initial temperature is also same. Final temperature is also same. It is constant. Okay. If I take the change of this temperature, what I have to do? Final temperature minus initial temperature I have to do, no? But both the values are same. Final is also 5 degrees Celsius. Initial is also 5 degrees Celsius. 5 minus 5 will be 0. So if the temperature remains constant throughout the process, we call that as isothermal process, and in isothermal process, delta T is equal to 0. Okay. If the temperature is constant, it is isothermal. What about isochoric? What is meant by choric? Choric means volume. So here volume will be constant. So delta B will be equal to 0. Okay. And for isobaric process, pressure is constant. So delta P is equal to 0. Clear? Isothermal means temperature, choric volume, baric means pressure. Clear? Now coming to cyclic. For cyclic process, I'll show you the picture, okay? So I'm starting from this point 1, reaching to point 2, and from 2 to 3, 3 to 4, and again I'm coming to 1. Initial point and the final point remains same. If it remains same, then the process is called as a cyclic process. Okay. So I am standing in point A and I'm going to point B and I'm coming to point C and again I'm going back to point A. So the initial point and the final point will be same for the cyclic process. Okay. Now coming to the last adiabatic process. Adiabatic means there is no heat exchange or the heat transfer between the system and the surrounding. Okay, there is no heat transfer between the system and the surrounding means heat is actually denoted by the letter Q. Q will be 0. No heat transfer, right? So Q will be 0 for adiabatic process. So this is all about the types of process. So do you have any doubt from these types of process, students? Shall I go for the types of properties? Shall I go for the types of properties? Yes, what about others? So all these are the very basics which you should know. Without knowing this, the other things will be very difficult for you to understand. Yeah. So now we'll go for types of properties. There are two types of properties. One is extensive property and the other one is intensive property. So first we will look into intensive, then we will come to extensive. Okay. What is intensive property? The properties which do not depend on the quantity of matter. Quantity means the size, okay, the size of the container or the size of the matter. The properties which do not depend on the size of the matter or quantity of the matter is called as intensive property. Examples are also given, you see, temperature, pressure. So let me take one example so that you will understand this better. You see here, I am taking an ice cube. So initially I have only one ice cube, and if I check the temperature of this ice cube using a thermometer, it is 0 degrees Celsius. And I am adding one more ice cube. I'm going to add one more ice cube. So if I add one more ice cube, I have two ice cube, right? Now if I check the temperature of these two ice cubes, still it remains as 0 degrees Celsius only. Okay. So now I have changed the quantity from one ice cube to two ice cube, but still the property, the temperature property remains same for both. So the property which do not change on changing the size of the system is called as intensive property. Is it clear to all of you? Any doubt from this? Okay. So now we will go for extensive. Extensive is the opposite of intensive. The properties which depend on the quantity of matter. The properties which depend on the quantity of matter. Like example, volume, mass. So what will happen? You see, I am taking 5 kilogram wooden log, 5 kilogram wooden log. 2 5 kg wooden log I am taking initially. Okay. Now, if I add those two, what will be the total mass? It will be 10 kilogram, right? The property is changing from 5 kilogram to 10 kilogram. Initially, I had 5 each, but finally, I have 10 kilograms. So, the mass is changing. So, mass is one of the property, extensive property. So, the value of that property is changing on changing the size of the system. Okay. So, from 5 to 10. So, it is an example for intensive property. Is it clear, students? Properties who do not change is called as intensive. Who changes is called as extensive. So these two are very important. And moving forward with this, I will ask you one question. 1 liter of water has density of 1 gram per milliliter. If the half liter of water is taken out from it, what will be the new density of water? So I am having a container in which water is present. Volume of water is 1 liter. Okay. And the density of this water is 1 gram per milliliter. Now what I'm going to do, if the half liter of water is taken out, if I take half liter out, what will happen to the density? Will the density remain same or it will change? If it changes, to what extent it will change? Will it change or it will not change? Let me know the answer for this. Will the density change or it will not change? What is your answer? It will change to half. I'll give you the answer. Half liter of water will also have the same density. It will not decrease. You know why? It is a density is an intensive property. Density is an intensive property. What is meant by intensive? The value does not change on changing the size of the system. Okay. So whether it is 1 liter or half liter or 2 liter, everything all will have the same density value. Okay. Density is an intensive property. Clear for all of you? So now let's go for, now let's go for the types of functions. We have two types of function. So we have studied 3 types of system, 5 types of process, 2 types of properties, and now 2 types of functions. Okay. Now coming to this first type, it is called a state function. What is meant by state function? The function which depends only on current thermodynamic state and not on how the process is obtained is called a state function. Only the initial and final state is required. Okay. Whether it has took this many steps to reach the final point or it has gone straightly from initial to final, that doesn't matter. It depends only on the initial and final state. So those functions are called as state function. I will show you an example. Here, for example, changing temperature in single step versus multiple step is given. So here you see, this is one path. Initial temperature and this is the final temperature and the change is delta T. It is going in a straight manner. Okay, the difference. And here you see, it is taking 3 steps. The reaction is taking 3 steps to get completed. So this is a final initial point, this is the final point, this is delta T. The delta T is same. The delta T value is same for both the steps. Whether the reaction is taking place in a single step or it is taking place in a multiple step, that doesn't matter. The temperature change, the delta T, depends only on the final and the initial value. Okay. So such functions are called as state functions. Such functions are called as state functions. So who remains same here? Delta T is same. Delta T is same for both. Not only temperature, some other examples are also there. I will give you that. So other examples are internal energy, enthalpy, volume, and pressure. Internal energy is represented by U, enthalpy is represented by H, volume is represented by V, and pressure is represented by P. So these are all the other examples of state functions. The examples under each case is very important. Okay. So you need to note down the examples. Shall I go for the next type? Shall I go for the next type, students? The second type of function? Yeah. The second type is path function. So what is meant by path function? The function which depends on the path focuses on how the final state is attained. Okay, how we are going from the point 1 to 2. So the entire path, if it is considered, then it is called as a path function. So see here. So this is point number 1, initial point, and this is the final point. And this is the path taken, path A taken for this reaction to happen from point 1 to point 2. So this is the red color lines as the area covered under this region. Okay. And coming to next, this is path B. We can also take this path. Okay. If I include the two, if I combine path A and path B, I will get this, no? So this is path A, this is path B, and this is path A and B. So it takes into account all the informations which are coming in between this. Okay, the entire thing is taken. Means it is called as the path function, and the examples are work and heat. Work is denoted by W, heat is denoted by Q. So except these two, all other functions are state functions. You memorize only these two. Okay. You memorize only the examples of path function, which are work and heat. The all other terms will go into the state function list. Okay. You don't have to memorize. Sit and memorize the state function examples. Just memorize these two. Except these two, all others are state. Clear for all of you? Now let me summarize the things that we have discussed so far. We have discussed about system surrounding and boundary, and intensive extensive property, state function and path function. So these are all the very important points that you have to keep in mind from the basics in thermodynamics topic. So do you have any doubt till this? Do you have any doubt till this? Is everything clear and okay? Fine for all? What about others? Yes? Good. Now the next main topic is first law of thermodynamics. So under this topic, we are going to cover these many subtopics: internal energy, law of conservation of energy, work, types of work, expression for work, enthalpy and internal energy, and heat capacity. Okay, let's do one by one. The first topic is internal energy. What is meant by internal energy? Let me take a system, okay, in which gas molecules are present inside the beaker, and this is a system. So we do have gas molecules, right? So one gas molecule will interact with the other molecule, and this is considered as a one molecule. So there will be some kinetic energy associated with this molecule. What is meant by kinetic energy? Kinetic energy can be in the form of translational energy, rotational energy, vibrational energy. Translational means, so the molecule will move from one place to another in the same direction. We call that as the translational. So one will be here and that one will go from this place to this place. It will move along in this single direction. Means some amount of energy is required to move from one place to another, right? So that is called as translational energy. And the molecule can rotate. No, the molecule can rotate here, here, and to all the sides it can rotate. So some amount of energy will be associated with it. If I'm rotating from this side to that side, I need some energy, right? So that is rotational energy. And what is vibrational? The bonds between the two atoms in a molecule will vibrate. So here you see it is getting stretched out and it can again come back. So that is called as vibration. So energy is associated with that and that is vibrational energy. So this type of translational, rotational, vibrational, so all these together is called as the kinetic energy of the molecule. Okay. Including to this kinetic energy, potential energy is also there for one molecule. What is potential energy? The energy which is already present inside the molecule due to force of attraction and also due to force of repulsion. Okay. So now if I add kinetic energy and potential energy, I will get one value and that value is called as internal energy of the system. Total kinetic energy of all molecule plus total potential energy of all molecule is equal to the internal energy of the molecule, internal energy of the system. Okay. The energy which is present inside the system is called as internal energy. Kinetic energy plus potential energy. Now let's see some properties of this internal energy. So first of all, it is dependent only on the change in temperature of the system. It is dependent only on the change in temperature. If temperature is increased, internal energy also increased. So, internal energy is directly proportional to temperature. If one increases, the other one will also increase. Okay. So, secondly, internal energy is a state function. It depends only on the initial state and final state. So, if I calculate the change in internal energy, it is final minus initial, that's all. Okay. And thirdly, it is an extensive property. What is meant by extensive? Whose value changes. The property changes on changing the quantity. Okay, if I change the quantity, internal energy also will change. And it is represented by the letter U, and the SI unit of internal energy is joules. Direct U cannot be measured. Students, can you all able to see my screen? Can you all able to see my screen? Students, am I audible? Can you all able to hear my voice? Veera Prasad, can you able to hear me now? Yes? Okay. All of you can able to see my screen, right? Sorry for the interruption. So it is a technical issue. So now, what I was saying, the last point of this internal energy is the total internal energy cannot be measured. Only the change is measured. Delta U is measured using an instrument which is called as bomb calorimeter. So only that is measured. Direct U cannot be measured. So these are all some of the properties of internal energy. All right. Screen is not visible. Can you all able to see my screen? What about others? Rakshita is saying that my screen is not visible. What about others? Can anyone give me a reply whether you can able to see my screen or not? Dinesh Verma, is it visible? Okay. Rakshita, can you able to see now? Okay, now let's go for the next topic, which is law of conservation of energy. So far I was telling you the properties of internal energy and its related informations. Now let's go for the law of conservation of energy. So the internal energy which we have seen that can be changed by three factors. Okay. One is due to the heat exchange between the system and the surrounding. Okay, the heat exchange between the system and the surrounding. And the other one is by the work done by on the system or by the system. And thirdly, internal energy can be changed by the matter entering the system or leaving the system. Okay. So internal energy is changed by heat and can be changed by work done on the system or by the system or the matter entering the system or leaving the system. Okay. So let me go for the heat. Some informations about heat. So heat is transferred from warmer object to colder object, right? Heat always transferred from warmer object to colder object. So if the heat is entering into the system, what will be the sign convention? What is the sign we have to use if it is entering? Do we need to use the sign plus or minus? We have to use plus. If the heat is entering into the system, then the Q value will be positive. Q value will be positive. If the heat is coming out of the system, then the Q value should be negative. Okay. If the heat is entering into the system, Q is positive. If it comes out of the system, then the Q value is negative. Okay. Now, what is the second thing? Second is the work done on the system. And thirdly, the matter entering or leaving the system. Now, using this, we'll go for the first law of thermodynamics, which states that energy cannot be created or destroyed. It can be converted from one form to the another. And this is called as first law of thermodynamics. It is represented by delta U is equal to Q plus W, which is a very important formula. You have to memorize. This is actually the first law of thermodynamics formula. And here Q and W are the path function. We have studied the examples for path functions, right? Heat and work. These two are the path function. And delta U, internal energy, is a state function. The addition of two path function will give the state function. Okay. If Q is equal to 0 and W is equal to 0, then delta U is also 0, right? If both are 0, then delta U is also 0. So delta U is equal to 0 for this case, for isolated system. Energy of an isolated system is always constant, because for isolated system, isolated means the flask we have to take, right? So the flask, the thermos flask. So there we cannot give heat and no work is also done on it. So both are equal to 0. So delta U will also be equal to, means it is constant. If something is equal to 0, it is constant. If delta U is equal to 0, it is constant. Why it is constant? The final value and the initial value, they are same. They are constant. That's why we are getting the value 0. Okay. Initial internal energy will also be 6. Final internal energy will also be coming out to be 6. So 6 minus 6 will be 0. Okay. If some change is coming out to be 0, then it means that the particular term is a constant. Okay. Energy of an isolated system is always constant. So this is all about the first law of thermodynamics, the very important definition and the formula of this lesson, of this thermodynamics lesson. Okay. So the next topic is work. So shall I go for the work topic today or shall I continue this tomorrow? Okay. So we will continue the work topic in tomorrow's session. So before moving on to the end of the class, I am launching a poll regarding the feedback. So You can give your answers over there and then you can leave. Okay. So thank you so much for attending the lecture, students. So meet you all in the next session. So try to be on time from next session onwards. So I have launched a poll. All of you have to answer for it. Please answer and then go.